Welcome to Brain Vision.
So here we are to state the order of the given differential equation here. So we have 2 dy dx plus y is equal to x minus 1. Let's call this, let's call this 1. And we then are to confirm that the functions in the family y is equal to c times e to the negative x over 2 plus x minus 3 are solutions. So let's call this here 2. Now, looking at 1, right, since the first derivative is the highest derivative that occurs, right, we only have a dy dx. We have 2 times dy dx. Here we have a first derivative here. There are no higher order derivatives. There are no second derivatives, third derivatives, or so on. So the highest derivative we have is a first derivative. Therefore, the order of this differential equation is 1. So the order is 1. Okay, now we go ahead and we differentiate 2 here. So we get dy dx is equal to, let's see, this is going to be negative 1/2 c e to the negative x over 2 plus 1. Okay, and well, we have 2 dy dx plus y is equal to 2 times negative 1/2 c e to the negative x over 2 plus 1 plus c e to the negative x over 2 plus x minus 3. Okay, so we have this is equal to c e to the negative x over 2 plus 2 c e to the negative x over 2 plus x minus 3, which is equal to x minus 1. So we therefore confirm that 2 is a family of solutions for 1. And then for part B, well, we have differential equation here. We have y double prime minus y is equal to 0. Okay, so let's call this 1. And we are to confirm that the functions in the family y is equal to c1 e to the e to the t. So c1 e to the t plus c2 e to the negative t are our solutions. So let's call this here 2. Now, looking at 1, again, we have a second derivative here, y double prime minus y. So since the second derivative is the highest derivative in this differential equation, right, the order is 2. So the order of a differential equation is just the highest order derivative that occurs. So since we have a second derivative here, the order of this differential equation is 2. Okay. Now, looking at the equation here, we go ahead and we differentiate both sides. So we get dy dt, differentiate with respect to t, is equal to, that's equal to y prime, right, which is equal to c1 e to the t minus c2 e to the negative t, and we differentiate again, and we get y double prime is equal to c1 e to the t plus c2 e to the negative t, which is equal to y, which implies that y double prime minus y is equal to 0. So therefore, it is confirmed that 2, right, that 2 here is a family of solutions of 1. Okay.